So when the potential difference between two charges causes a third charge to move, that charge would be an electron in motion. It's called electric current. So the movement of the electron is current, which is measured in amperes, which is named after Andre Ampere. So current is a continuous flow of electrical charges. So essentially what current is trying to balance out this imbalance. So when you go out to your car and you put it on accessories and you can listen to your stereo. Well, what's happening is your battery in your car, there's a chemical process. You have a hydrosulfuric acid in there, and you have, they call lead and sponge lead, which is lead oxide of some sort. And so essentially, the acid is working on those two, and one of those is you get an excess of electrons. It takes them off of one and puts them on the other, and so you have a lack of electrons on one plate, and you have excess electrons in the other plate. So then your stereo essentially is the excess of electrons go through your car, your frame, up through your stereo, all the way around to back to your battery, trying to balance out the coulombs of this imbalance to get it back to neutral. If you leave it on long enough, your battery goes dead, and you'll have no charge difference between those two. And so essentially what happens is in the H2SO4, the sulfur comes out of the H2SO4, attaches itself to your lead plates, and then you have water and lead sulfite, sulfide, and then you have to put more energy. So if it's 1.5 volt per cell, it takes about 2.5 volts or so to reverse that chemical process to get it to charge. So if it's a 12.6 volt battery, you can't put a 12.6 volts on there and expect it to charge. You have to put about 15 volts on there to break down that chemical process to take that. Now we have a chemical bond we have to overcome, and we have to take the sulfur away from the sponge lead and the lead and put it back into the water to form acid. Sometimes when you're charging a battery, if you have the voltage too high, that chemical process is violent and it gives off gas, and the little holes in your caps aren't enough, and the battery can actually explode if you either try charging it backwards or you put too much voltage to it, and the chemical reaction can become violent. So here we have a chemical, it's 1.5 volts. It has a battery symbol. The short bar is always going to be our negative. The long bar is always going to be our positive. And so current, as we know, goes from the negative to the positive to, and so the movement of these electrons, we have a lack of electrons over here, so it's a minus Q. We have an excess of electrons over here, it's a plus Q. So there's a difference of potential. And so these electrons are going to come over and try to equal out this imbalance. So this current and charge, this is called Ohm's law, and we'll be talking about that. But we can learn how to measure this. We can learn how to control this, the number of current flowing. So that's another chapter. But essentially, the rate of flow of current is called current amperage, and the symbol is A. So if we get 1 coulomb of electrons, or 6.25 times 10 to the 8th electrons, flowing past a given point in a wire. So if you sit there with a counter and you can count the electrons going through one point in that wire, you can convert that number of electrons in time to amperes. So 1 amp or 1 coulomb in a second is 1 ampere.